proving, what I asked you to prove rhombuses using coordinate geometry. So I asked you to fill in this table. Coming down to this bottom one, it says prove all sides are, what do all sides have to be?
Congruent.
Okay, so congruent, and that's the definition to be a rhombus. So we're looking there at the distance formula. All right, so now up here, just like the other shapes that we talked about, we first have to show it's a parallelogram. But we're going to first show it's a parallelogram. Then if we show that it has what additional feature will allow us to make it a rhombus?
The diagonals have to be perpendicular.
Okay, good. We want perpendicular diagonals here. So all right, and that means that we have to look at slopes.
Did you put that one for number 2?
Yeah, whether you've got that as option 1 or option 2 would be fine. So slopes are opposite sine reciprocals. Maybe even want to write slopes of diagonals. It's the tray on my whiteboard. I'll get you guys set up. Grab a seat in the hallway and I'll get you set up here in a minute. Part 2 says prove that it's a parallelogram. Now the additional component that shows a parallelogram is also a rhombus. Is that if essentially in a parallelogram, don't we know both pairs of opposite sides are congruent?
Yeah.
So if we're able to show that, it's this idea here, and give you the visual, it's this idea here. If it's a parallelogram, we know this. Both pairs of opposite sides congruent. But if I can do this, make that side maybe congruent to that side, does that make then this side over here have 2 marks in it?
Yeah.
Okay, so these 2 sides would be considered what to one another? Consecutive. So we want to show that it's a parallelogram with consecutive sides congruent. Okay, and again, that's going to be using the distance formula. So if you wrote those, obviously you can write those in different order. Now we want to prove that this shape down here is indeed a rhombus. So obviously the hopes are that you plotted those points, which are in being located at 1, 5, E, -1, 2, W, 1, -1. All right, so you plotted those points, you connect them. Let's see here. All right, so we got that shape there, right?
Yeah.
Now the question is, can we go through and determine the slopes maybe? Okay, it says prove that's a rhombus, and on its way to being a rhombus, this is kind of every time we do one of these things, this might be something you want to kind of write on the side. First, is it a quadrilateral? Obviously that is true, right? We then need to go second, is it now a parallelogram? All right, so we're going to go to that route. And then, if it's a parallelogram, we should be able to determine or decipher whether it's a rhombus or not. Okay, so first thing we need to go through is see if it's parallelogram. There's a lot of different ways you could do this, and this is the kind of the issue that we run into in regards to demonstrating this in class and talking about this in class, is that there are, if we come back up here from yesterday, there's 5 different ways that you can prove something to be a parallelogram, right? Okay, now we're not going to use this way here, so let's say there's 4 different ways. Okay, so in this situation, we have 4 options there to show us something's a parallelogram. To show something's a rhombus, where's that? Okay, to show something's a rhombus, we've got these 2 options, and then this one, right? So there's really 3 things that we could do to show a rhombus. Now, maybe there might be 1 or 2 ways there that actually could be a little bit easier than showing it. Like I said, for instance, if I wanted to show that it's a rhombus just based off of all 4 sides being congruent, if I do that, I don't have to show it's a parallelogram. Does that make sense? Okay. But when I write this, I got 4 ways to show a parallelogram and 3 ways to show a rhombus. That means I've got 12 different approaches that should get me to the answer here. Does that make sense? Now I say 12, but 1 or 2 of those might be, I could go straight to showing it's a rhombus without having to go through the parallelogram. So it might only be like 10 approaches or 9 approaches that really are different. But that being said, 9 different ways of doing the problem is still a lot of different ways, right? So you may do it a little bit differently than the way I do it. I think one of the most common things for people and most obvious is maybe to deal with slopes. Okay, and dealing with slopes is not a hard process. So I like to use those. So let's talk about our slopes here. If I have, just want the names of these things. Find the slope of n to y. So I'm going to take 5 minus 2, right? Gives me 3 up top. Take 1 minus 3. Gives me negative 2 on the bottom, right? So slope of ny is negative 3 halves. It might be a good idea to label slope ny. Come down here, do the same thing. 2 minus negative 1 would give me 3, right? 3 minus 1 would give me 2. So there's a slope of wy. 2 minus negative 1 would give me 3. And then negative 1 minus 1 will give me negative 2. So slope of EW is negative 3 halves. And you come up here, find the slope. 5 minus 2 is 3. And then 1 minus negative 1 is 2. So we find those 4 slopes, right? Is that doable? Okay. So if I found those 4 slopes, would you agree that the 3 halves and the 3 halves for those 2 sides are the same? So that so far is one side of parallel sides, or one pair of parallel sides. Would you agree that negative 3 halves and negative 3 halves are the same?
Yeah.
So have we just shown now that's a parallelogram? Yeah. And we would probably want to write that we've shown that both pairs of opposite sides are parallel because slopes are the same. Thus, this thing's a parallelogram. Now we want to go through and determine if it's a rhombus. Well, here's the thing. You have options to show it's a rhombus. I think the number 1 option that people probably want to use is showing distance, especially if I've already used slopes here. Because I've already got all the components I need to find distance if I know what the slopes are. Okay? Or you can look at the diagonals being perpendicular. That might be an easy thing to do. But if I want to show the diagonals perpendicular, what do I need to know about those diagonals? I need to know 2 more slopes, right? So I need to do the slope process 2 more times, where it might be a little bit more efficient to just look at distances. The reason I think I should look at distances, let's remind ourselves what the distance formula is. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay? Would you guys agree? Let's say I want to find the distance of ny. I want to find that length. Would you agree that that quantity right there, that 3, is your y2 minus y1? And that there, that negative 2, is x2 minus x1. And those are the exact same components that come down here in this formula. So let's do this. x2 minus x1, well, that's a negative 2. What's negative 2 squared? 4. And now I'm going to take the y2 minus y1, which is the 3. What is 3 squared? 9. Was it really easy to find that distance once I knew what the slope was?
Yeah.
Yeah. Okay. So the distance of this segment here into y is root 13. Okay. I just want to check, see if this will work. I've been messing around with something. Click on that. Okay, so now I'm going to say, I go surd text what is that? 3 point, let's go, should be F. Does give me the radical 13, okay? Now, if I go through and maybe I want to find the distance of this segment, okay? Finding the distance of that segment, which is WY, distance of WY. Would you agree that that 3 right there is your Y2 minus Y1? Okay. Would you agree that that 2 right there is X2 minus X1? So what's 3 squared? 9. What's 2 squared? 4. Do I still get root 13 right there? Okay. Now, as I go around this rhombus, are all those 3s and 2s? So I'm always going to, when I square, get a 9 and a 4? So would you agree that all sides are radical 13? Okay. But I don't really need to go and do the additional 2 sides, because think about this. If I'm just going to clear some things up here. We have shown that this is a parallelogram. So we know those 2 things are parallel, those 2 things are parallel. And now we found that this was root 13, and that is root 13. Have we shown that those 2 things are congruent? Are those consecutive sides? Does that match up with this phrase right here? It says prove that it's a parallelogram with consecutive sides congruent. Does that make sense, everyone? Now, you may be a person, and it's a special case scenario, I think, in this one, where let's say you don't like doing slope, or you didn't want to approach it that way with the distance formula. There is an alternative way, and I think maybe this is a technique that the more you come across this problem and see this problem, maybe you address it this way. What kind of line is J there? It's a diagonal, but in regards to its, it's vertical, right? So that's a vertical line. So slopes of vertical lines are always what? Undefined, okay? Because your x2 minus x1 is going to be this here minus that there, right? And in your denominator, you get 0, and you can never divide by 0, right? So your slope is actually here, 6 divided by 0, which we know that's undefined, okay? And then this is a special case, if your x values are ever the same for endpoints, you're always going to have a vertical line. What kind of line is this here? Horizontal. And that's horizontal because your y values are the same, right? Y value of 2 there and a y value of 2 there. So what is your slope there going to be? Yeah, slope is 0. So ultimately what that tells us, if we find a slope that's undefined and a slope that is 0, we have a line that is vertical and a line that is horizontal. And just by definition what those things are, any line that is horizontal is what? Any other line that's vertical?
Perpendicular.
Perpendicular. Does that show your diagonals are perpendicular to one another?
Yeah.
Okay, and that's a fact that if we show that, we prove it's a rhombus. Okay, so that's an option. Now they're not always going to be 0 and undefined. You might actually go through and find the slopes of those lines if they're, they could be different. Okay, they could be both numerical quantities, and if they're opposite sign reciprocals, then they're perpendicular. Okay. Beyond saying opposite sign reciprocals, what's another property that shows us things are perpendicular? For instance, if let's do it this way. Let's say that I've got let's just put a point out here somewhere. Put that point there, and let me take. Take all these segments and rotate them around that point. Actually, I think I got to do it this way. That stuff about that point, 150 degrees will work. Now, I'm not sure why it shows all these extra quantities here, but let's see if we can maybe hide them. Would you guys agree if I showed those 2 points and those 2 points, if I went through and looked at their ordered pairs, they're pretty ugly ordered pairs, so let's go down to like 3 decimals. Can we find a slope of those things? But when I find the slopes of those things, slope of that line, oh, that was distance. If I find the slope of that diagonal, which is that number right there, and the slope of that diagonal, which is that number right there, right? Are those easily determined? Can you change those to a fraction real easy? No. If it was like 1/3, that'd be, or 0.3 repeating, that'd be easy. If it's 0.5, that'd be easy. If it's like 0.1 repeating, that would be easy. Okay. But changing those numbers to fractions is not the easiest thing to do. What if, because I believe those numbers will also look like this. Let me see here. Those numbers can also be written this way. This number right here is the negative radical 3/3, and this one here is radical 3. Okay? So they're irrational numbers. However I view them, it might be hard for you to recognize that they are opposite sign reciprocals, right? If I view them in the blue stuff in the graph, they're not even fractions, written as fractions, right? So I can't determine reciprocals. But by definition, we've talked about reciprocals being the idea that if I've got m being my number, its reciprocal would be 1 over m, right? Would you agree with that? Well, if I multiply those things together, don't I get m over m? So what's that give me? 1. Okay? Well, if they're opposite sign reciprocals, that would mean that one of these would be positive and one of them would be negative, right? That gives you negative m over m, which would give you negative 1, right? So we have a property that says if these two things are indeed in fraction form, opposite sign reciprocals, their product should be negative 1. The slope of two lines that are perpendicular, their product is always negative 1. So I should be able to take my calculator and go m1 times m. Okay, so that's multiplying these two numbers together. And if it evaluates to negative 1, which that's that number right there, m1 times m, you see it does evaluate to negative 1. So it proves to us that this angle here, I need another point, it proves to us that that angle, even though when we developed this figure, we never developed this figure with this angle in mind though, right? If I look at that angle, is that angle a 90-degree angle? Yeah. And it develops to be 90 degrees because the idea that that thing is a rhombus, because all 4 sides are congruent, and then all these other properties kind of take place. They take place because of what we know essentially about triangles. But that's a way for us to determine, if I can't look at those numbers as fractions and recognize that they're opposite sign reciprocals, you should still be able to multiply them together and see if you get negative 1. And if you do, they're perpendicular. Is that doable? All right. That perpendicular concept, opposite sign reciprocals, is going to be something that plays over and over and over again in all the courses that you take from here on out. So that's why I talk about it quite a bit, because it becomes a particularly important relationship as you get to other classes. All right, this one here, when we get down to page 4 on top of it, asks you to determine whether something was a square, right? Well, if it's a rectangle and a rhombus at the same exact time, does that make it a square? There's a rectangle and a rhombus at the exact same time, it's a square. So if I say it's a rhombus with a right angle, it's a square, right? Or if I say it's a rectangle with maybe consecutive sides congruent, it's a square, right? Or if I say it's a rectangle with diagonals perpendicular, it's a square. Okay? Cool. Thank you. So what we're looking at here then, it says prove that it's a rectangle. And I'm going to write here with rhombus features. Okay? And maybe that means perpendicular diagonals. Or maybe consecutive sides congruent. If you're able to show first that's a rectangle, so show you have a right angle, and then go through and say, okay, well, diagonals are perpendicular, or consecutive sides are congruent, then you've got enough to show that thing is a rectangle and a rhombus. Therefore, it has to be a square. This statement here proved that it's a rhombus with what type of features? Yeah, rectangular features. So meaning that it's a rhombus with, think about what kind of differentiated a rectangle is that it had a right angle, right? So let's say at least one right angle, because if it has at least one right angle, it's going to have four. It's already a parallelogram. Or maybe we look at the fact that what are the diagonals of a rectangle? Congruent. So if you can show those types of things, you now are able to progress from a quadrilateral all the way down to a square. As you do these, and I'm going to freeze this real quick for you and try to pull this up before we leave. We've got, what was it? Y is equal to 1, negative 4, E is at 3, 0, A, negative 1, 2, and R is negative 3, negative 2. Negative 1, 2, negative 1, 4. 1, negative 4. Okay, so that's the oh. It's a 2 I want there. Okay, so that's the shape that they're asking you to deal with in that first question on the square. And this is what you want to do. Is it a quadrilateral? Yes, right? We then want to say, okay, is it a parallelogram? Okay. Well, if it's a parallelogram, we're going to go find. In the event of finding whether it's a square, I think the safest and fastest thing for you to do is to first show it's a parallelogram by looking at slopes. Because if you can find those 4 slopes, it will automatically tell you once you have them whether it's going to be a rectangle or not. So if I go 2 minus 0 is 2, negative 1 minus 3 is negative 4, right? 0 minus negative 4 is 4, 3 minus 1 is 2. Negative 2 minus negative 4 is 2. Negative 3 minus 1 is negative 4. And then here, 2 minus negative 2 is 4. Negative 1 minus negative 3 is 2. So are these opposite sides, are they parallel? Are these opposite sides parallel?
Yeah.
So it's parallelogram, right? And now here's the benefit of doing it that way, is because if now I've looked at those, can I look at that one there, negative 2/4, and look at that one there of 4/2, and determine that those are opposite sign reciprocals?
Yeah.
So what's this got to be right here?
Right angle.
A right angle. And if it's a parallelogram with one right angle, have we now shown it's a rectangle?
Yeah.
Yeah, okay. So here's also the benefit. Now it's a rectangle. Let's go see if it's a rhombus. Well, to be a rhombus, doesn't this side right here have to be congruent to that side right there? Do you have your y2 minus y1 and your x2 minus x1 for your distance formula?
Yeah.
So if I find distance here, distance is going to be equal to negative 4 squared, which is 16, positive 2 squared, which is 4. So distance is radical 20, right? Come down here. When I find the distance of this side, e to y, is it still 4? I square that, I still get 16, right? Is it still 2? All right. So I still get distance is equal to radical 20, right?
Yeah.
So are these two sides still congruent? So you've shown now that it is a rhombus. And if you've marked all those things off, if it's a parallelogram that's a rectangular rhombus or a rhomboidal rectangle, then it's automatically a square. Okay? So in proving that it's a square, essentially all we have to do is slope, right?
Yeah.
And then kind of mess with those numerators and denominators to find the distance, but that's the way you do it. Now be careful when you do that, because 4 over 2 reduces to 2, right?
Yeah.
But if I reduce it to 2 and then try to find the distance using that, 2 over 1, I'm not going to be able to make the right distinction. So when I'm trying to use my slope to help me find distance, you have to do it with the unreduced version of the fraction. Okay? That last page, I think it's page 7. There's 3 questions on that. Have those completed when you come to class tomorrow. Some of you are not going to be here tomorrow, right?
Yeah.
How many of you are not going to be here because of 411 day? All right, what time do you get back? After lunch? Okay. All right, that might dictate what we do in class with everybody else, but please have that page 7 done for tomorrow.